Welcome to part 1 of electricity. We'll be exploring static electricity, insulators, conductors, and the dynamic electricity. Matter is composed of atoms. There are approximately 118 different types of atoms in the universe. Between 92 to 98 of them occur naturally, while the rest are man-made. A certain amount of each type of atom come together to form elements. The periodic table is a chart that organizes chemical elements into rows and columns. All of the elements in the universe can be found on the periodic table. Atoms are composed of 3 types of particles. We refer to them as subatomic particles. They're the protons, which are the positive particles, the neutrons, which are the neutral particles, and the electrons, which are the negative particles. An atom has no charge, hence it is neutral because they have the same amount of positive as well as negative particles, giving it a total charge of 0. For instance, in the carbon atom, it has 6 protons, 6 positive particles, and it has 6 electrons, 6 negative particles, which pans out to 0. Here is the structure of the atom. An atom has a nucleus, and that nucleus is surrounded by energy levels, or another word for energy levels would be orbitals or energy shells. In the nucleus, you will find the proton and the neutron. And outside of the nucleus, you will find the electrons. The electrons can be found in the energy levels. Atoms can become ions, which are charged particles. They can do this by either losing electrons to become positively charged or by gaining electrons to become negatively charged. There are different types of positive particles, and there are also different types of negative particles. We'll be referring to them in this chapter. The types of charged particles that we will be referring to throughout this lesson would be the proton, the electron, the cation, and the anion. The proton and the cation are both positive particles, while the electron and the anion are both negative particles. Proton and the electron can be found in the atom. They are subatomic particles. The proton can be found in the nucleus of the atom, where the electron orbits that nucleus in something called an energy shell, or it can be referred to as an orbital, or it can even be referred to as an energy level. Cations and anions can be found together in the air, in electrolytes, and they can also be found in plasma. A cation is usually formed when an atom loses electrons, and only certain types of atoms lose electrons to become positive. While an ion can be formed when an atom gains electrons, and only certain types of atoms gain electrons. It's important to note that opposite charges attract, while like charges repel. And neutral objects, because they have no charge, they're not attracted to each other. Most materials are neutral. Rubbing materials together can cause friction, and this causes the movement of electrons from one material to the other, and we call this electron transfer. The only particle that moves from material to material is the electron. The balloon and the rag below are neutral. This means that the number of electrons is equal to the number of protons in each of the objects. Now, in this case, the balloon contains 6 protons and 6 electrons, while the rag contains 4 protons and 4 electrons. Please note that this is just an oversimplified drawing to explain why insulators are neutral before rubbing. They have way more protons and electrons in them. In a very dry environment, if the balloon and the rag are rubbed, the charges on each object will become imbalanced. In this case, the rag will become negatively charged, while the balloon will become positively charged. This will happen because the electrons will leave the balloon's surface during the rub and populate the surface of the rag. Friction causes static electricity to occur in insulators. This is what has happened between the balloon and the rag. They are insulators. Eventually, the balloon will gain electrons and the rag will lose its excess electrons to become neutral again. This will happen when they come into contact with another surface that is neutral. Protons and neutrons do not move because they are trapped in the nucleus. This is a very important piece of information. This is why the electron is able to be rubbed off of insulators. Now, there are two types of electricity. We have static or triboelectricity, and we have dynamic and current electricity. Static electricity is the imbalance of electric charges within or on the surface of a material, like we saw with the balloon and the rag. The charge remains until it is unable to move away by means of an electric current or electrical discharge. The transfer of electrons results in both of the materials becoming electrically charged. When extra electrons enter an object, the object becomes negatively charged. And that is why the rag became negatively charged. And when electrons leave an object, the object becomes positively charged. So the balloon became positively charged. Please note that the nature of each type of insulator determines whether it will become positively charged or negatively charged because they have been rubbed. The list on the right gives us an idea of which types of material prefers to be positively charged and which type prefers to be negatively charged. The ideal condition or environment for static electricity to occur is when humidity is low, therefore the air must be dry. Humidity is marked by a relatively high level of water vapor in the atmosphere. Static shock due to friction is often experienced in air-conditioned or cool to very cold room. The most popular case of static electricity due to friction is electron transfer, as earlier discussed. However, there are other ways in which friction can cause static electricity to occur. Other mechanisms include the transfer of mobile ions from one surface to another due to rubbing, bond breaking to form charged particles due to rubbing, and the presence of a very, very thin layer of water existing between two pieces of material, experiencing charge separation when the two pieces of material are separated. Insulators. An insulator does not have mobile electrons within it, hence it cannot conduct electricity. Examples include cotton, fur, leather, plastic, silk, and wool. Here are some everyday examples of static electricity. You have lightning, you have garments sticking to our bodies, hair getting charged and sticking straight up, particularly in the winter time. Just after a television set is turned off, hairs on arms stand on end when placed close to the television screen, and when we rub our feet on the carpet. What happens is that we become positively charged as we rub off electrons from our bodies. Some uses or applications of static electricity are spray painting, photocopy machines, and printers. Conductors. A conductor is a material that allows negative particles to pass through it within a closed circuit. An electric current is the flow of negative charges through a conductor, for example, the metal wires. Water is a good conductor of electricity, but a poor conductor of heat. Other examples of conductors are metals, graphite, and ionic solutions, which are referred to as electrolytes. Metal and graphite conductors can conduct electricity because they contain mobile electrons in them. Conductors that are electrolytes conduct electricity because they contain mobile ions within them. Examples of electrolytes are strong acids like hydrochloric acid, weak acids like citric acid, strong bases like sodium hydroxide, weak bases like water, and basic salty water. When salt is added to water in its solid form, it dissolves and breaks apart into mobile ions. In this case, the salt is sodium chloride. When sodium chloride is added to water, it breaks apart into sodium ions and chloride ions. Positive ions are referred to as cations, and negative ions are referred to as anions. Examples of cations are sodium, calcium, potassium, and magnesium cations. Examples of anions are fluoride, chloride, nitride, and sulfide anions. Please note that the size of the ions are not a true depiction of their size in comparison to each other. In a process known as electrolysis, electrolytes or molten ionic substances conduct electricity by completing the circuit to make an electrolytic cell. Electrolysis involves using electricity to break down electrolytes to form elements. The flow of electricity in this system is due to the presence of both mobile electrons that you find in the wires and mobile ions that are present in the electrolyte. During electrolysis, the cell powers the electrolytic cell and forces electrons into the negative electrode, referred to as a cathode. Cations are attracted to the cathode. The electrons enter the cations, transforming them back into their elemental state. The anions are attracted to the anode. They give up electrons, which causes them to return to their elemental state. The electrodes may either be made of metal or graphite. You may be wondering, how are electrons able to move when insulators are rubbed but aren't able to conduct electricity? Electrons are tightly bound in insulators. For an electric current to move through a substance or component, it must contain either mobile electrons or mobile ions. Since electrons are immobile in insulators, they have to be physically rubbed off. A power source is unable to do this for an insulator. Power sources like cells work for conductors because the electrons in metals and graphite and the ions in electrolytes are already mobile. Hence, when energy is supplied, the electrons finally gain enough energy so that they can flow freely through and around a closed circuit. Dynamic or current electricity refers to the movement of negative particles through a conductor within a closed circuit. The SI unit of electricity is amperes, which has a symbol of capital letter A. The amount of electricity passing through a circuit is measured using an ammeter. This is the symbol for the ammeter when drawing a circuit. Flowing current is directly proportional to the applied voltage and inversely proportional to the resistance in the circuit once the temperature remains constant, where I is equal to V over R, or current is equal to voltage over resistance. The relationship between current, voltage, and resistance is expressed by Ohm's law. Resistance is the opposition to the flow of an electric current. The greater the resistance, the less current flows. The SI unit of resistance is the ohm. The Greek symbol omega is used as the symbol for ohm. The resistance of a wire is affected by its length, thickness, and the material from which it is made. Current flows best in short, thick wires. More electrons flow in thicker wires. They also have a shorter distance to travel in shorter wires. Long, thin wires have a high resistance to electron flow, and it also allows for less electrons to flow through it. Aluminum, which is a type of metal, has a higher resistance to the flow of electricity than copper, which is another type of metal. Variable resistors are used to change the current in an electric circuit by changing the length of the path that the current flows through. In circuit drawings, the symbol below is used to represent variable resistors. They are used to control the volumes in radios and television sets and in dimmer light switches. Regular resistors are placed in circuits to control the flow of current traveling through them. They also protect appliances from getting damaged by an overload of current, which can lead to electrical fires. In circuit drawings, the symbol below is used to represent regular resistors. So you can either use the top symbol or the bottom symbol. Voltage is provided by the power source. It pushes the electrons or negative charges around a closed circuit. The SI unit of voltage is volts, which uses the symbol capital letter V. A voltmeter is used to measure the voltage across a component. When drawing circuits, the symbol for the voltmeter is the one you see below. Current, voltage, and resistance are related. Again, it is referred to as Ohm's law, where V is equal to IR. If you transpose for current, you'll get I is equal to V over R. If you transpose for resistance, resistance will be equal to voltage divided by current. Electricity is like a water hose. Voltage is the pressure the electrons experience in the conductor, while current will be dependent on the size of the wire or the conductor, and resistance is dependent on the material used. This is a great depiction of how voltage, resistance, and current affect each other. Comprehension. Question and answer. What is matter composed of, and what is the periodic table? You may pause this video to answer these questions. Matter is composed of atoms. The periodic table is a chart that organizes chemical elements into rows and columns. Comprehension. Fill out the table with the correct words. So look at the table carefully and think about what you need to write for A, B, C, and D. You may pause this video to answer this question. Correct. A is the proton. Proton is positive and can be found in the nucleus. B is neutral because neutrons are neutral and they too can be found in the nucleus. D is negative because electrons are negative. Comprehension. So now we have true or false questions. You're going to state whether the statements are true or if they're false. You may pause the video to answer these questions. So here we go. An atom is neutral because it has the same amount of positive and negative charges. Protons and electrons can be found in the nucleus. Like charges attract. There are about 118 different types of atoms in the universe. Again, you may pause this video to answer these questions. Answers. So an atom is neutral because it has the same amount of positive and negative charges. Protons are found in the nucleus, while electrons are found in the energy levels or orbitals. That's why that statement is false. Like charges do not attract each other, they actually repel each other. So that statement is false. The last statement is correct. There are about 118 different types of atoms in the universe. Comprehension. True or false again. So you're going to say whether the statements are true or false. So let's go. Insulators contain mobile electrons. Graphite conducts electricity because it contains mobile electrons. The chloride ion is an example of a cation. And the positive electrode is the anode. You may pause this video to answer these questions. Insulators do not contain mobile electrons, so statement number 1 is false. The second statement is true. Graphite conducts electricity because it contains mobile electrons. Chloride ions are not cations, they're actually anions because they have a negative charge. And the positive electrode is indeed the anode. This is why this statement is true. Comprehension. There are 2 types of electricity. What are they? And to explain what each type of electricity is. You may pause this video to answer these questions. There is static and dynamic electricity. Static electricity is an imbalance of charge due to friction, while dynamic electricity is the flow of negative charges through a conductor in a closed circuit. Comprehension. Use the list below to categorize the materials as either an insulator or a conductor. So the list of words as follows: glass, gold, graphite, rubber, leather, salty water. You're going to use these words and place them under the correct column. You may pause this video to answer these questions. Great, I hope that you got glass, rubber, and leather as being insulators, and gold, graphite, and salty water as being conductors. Comprehension. Label parts A, B, C, and D in the diagram on the left. You may pause this video to answer the question. Awesome! So if you got A as the cell, give yourself a round of applause. B is the anode, C is the cathode, and D is the electrolyte. Very good. Comprehension. What is an electrolyte? And 2, give an example of an electrolyte. You may pause this video to answer your questions. Electrolytes are solutions that contain mobile ions and they conduct electricity. Examples of electrolytes include salty water, hydrochloric acid, nitric acid, etc., etc. Comprehension. What is the name of the structure below? You may pause this video to answer the question. The name of the structure below is graphite. Comprehension. What is the SI unit for current? And 2. What instrument is used to measure current? You may pause this video to answer the question. The SI unit for current is the ampere, and the instrument used to measure current is the ammeter. Comprehension. What is resistance? What is the SI unit for resistance? And there's 3 reasons why circuits experience resistance. You may pause this video to answer the question. Resistance opposes the flow of current through a conductor. The SI unit for resistance is the ohm, and the length of the wire, the type of material the wire is made up of, and the diameter of the wire are all 3 reasons why circuits experience resistance. What is voltage? What is the SI unit of voltage? You may pause this video to answer these questions. Voltage is the pressure applied to the negative charges to flow through a conductor in a closed circuit. It is supplied by the power supply. The SI unit of voltage is volts. Comprehension. Identify what each of the drawings below represent. You may pause this video to answer these questions. Great, if you got these answers, excellent. Part 2. We'll be exploring circuits and electricity in the home. Circuits. An electric circuit is a complete path in which electricity can flow. In order for an electric current to flow, an electric circuit must have A, a complete path, B, a conducting path, and C, a power source. Let's familiarize ourselves with circuit symbols. First, we have the wire. The wire is made from a metallic conductor, so current can easily pass from one part of the circuit to another. The cell supplies the electrical energy to the circuit. The larger terminal on the left is the positive terminal. A battery is more than one cell. A lamp converts electrical energy to light energy. A voltmeter is a device that measures and displays voltage in electrical circuits. Voltage is also known as electrical potential difference, and it indicates the level of electrical energy in a circuit. An ammeter is a device that measures the current in a circuit. The name comes from the unit used to measure electric current, the ampere. A resistor is a 2-terminal electrical component that introduces resistance into an electric circuit. Resistors are passive components, meaning only consume power and can't generate it. A variable resistor is a resistor of which the electric resistance value can be adjusted. A variable resistor is in essence an electromechanical transducer and normally works by sliding a contact or wiper over a resistive element. Variable resistors have resistances that can be adjusted either manually or electronically. Examples of variable resistors are rheostats and digital potentiometers. A fuse is a safety device that protects an electric circuit from becoming overloaded. Fuses contain a length of thin wire that melts and breaks the circuit if too much current flows through it. A switch in the open position means that the circuit is broken so no current flows. Once the switch is in the closed position, the circuit is complete and current is able to flow through it. There are two types of circuits. You have series circuits and parallel circuits. In a circuit, an ammeter is placed in series, while a voltmeter is placed in parallel. In a series circuit, there is only one path for the current to flow. If one part of the circuit is broken, no current flows because there is no pathway for the current to make its way back to the other end of the cell. In the series circuit, the current may be increased by adding another cell or removing a light bulb. In a parallel circuit, there are two or more paths for current to flow. If one branch is broken, current still flows in the other branches because there is still a complete circuit without the current having to go through the broken branch in the circuit. All of the equations that refer to the calculation of current are based on the conventional flow of electrons. That is why a lot of textbooks would still use it today. The fact is, in a closed circuit, electrons leave the negative end of the cell, travel around the circuit, then re-enter the cell via the positive end. This is referred to as the electron flow. It's okay if you use both. Just be mindful of which one is which. Electricity has a wide variety of uses in cities, business places, homes, and industries to operate devices, appliances, and machines. For instance, electricity is used in lighting, transportation, cooking, cooling, and communication. Sources of electricity include main supply, dry cells, car batteries, generators, and solar cells. There are many advantages of electricity. Electricity is efficient, it's readily available, it does not pollute, it can be transmitted over long distances, and it can be easily converted to other energy forms. Electrical energy is energy related to forces on electrically charged particles and the movement of those particles. Energy can be thought of as the ability to do work. Nothing happens without energy. Even when you are asleep, your body needs energy to keep you alive. There are different forms of energy. You have electrical energy. This is energy transferred when an electric current flows around a circuit. You have kinetic energy. This is energy an object has due to its movement. Then there's potential energy, which is stored energy. There's chemical energy. This is energy stored in substances, example food and fuel, which is released in chemical reactions. Then you have sound. This is energy transferred in sound waves. There is light energy. This is energy transferred in electromagnetic waves. Then there's nuclear energy. This is energy released from the nucleus of atoms when radioactivity is produced. Then there's solar energy. This is energy from the sun. And heat energy, energy due to the temperature of an object. The conservation of energy states that energy is neither created nor destroyed. It only changes from one form to another. Some energy is wasted during useful energy conversions, often as heat energy. Scientists have looked at lots of energy changes, like lighting a bulb, and have carefully measured the total energy before and after the change. They found that the total energy before change is equal to the total energy after a change. Examples of energy conversions include watching a television, where electricity flows through the wires and then into the television to power it up. So we have electrical energy being converted to light energy, sound, and heat energy. Or like shining a torch. Cells in the torch power the torch via chemical reactions that occur within it. This provides energy for the electrons to travel along the wires. So we start with chemical energy from the cells, which gets converted to electrical energy in the wires, which gets converted to heat or light from the lamp. Solar panels use energy radiated directly from the sun to heat the water that circulates through the black panels we see on some roofs. So we start off with solar energy from the sun, which is converted to heat energy that is stored in the water inside of the solar panel system. A nuclear power station uses radioactive atoms, for example uranium-235 atoms, and they're used to produce large amounts of heat to heat up cold water in nuclear power stations. The heat generated heats up the water until it turns to steam that has enough energy to blow on the blades of turbines, which causes them to turn and then generate electricity. So we start off with nuclear energy from the atoms, which turns into or transforms into heat energy, and then it is converted to kinetic energy by turning the turbines of the generator, and then eventually electrical energy, which travels through the wires and powers our homes. The appliances we use at home are not 100% efficient, and so they waste energy during energy conversions. For instance, the useful energy for a fan is kinetic energy. It wastes sound and heat energy. A cake mixer's useful energy will be kinetic energy, and sound and heat are wasted energy. Then we have the light bulb. The useful energy of a light bulb will be light energy. Heat and sound energy are often wasted energy when it comes to light bulbs. Electrical power is a rate of transfer of electrical energy. It is the rate at which work is done. The power of an electrical appliance tells us how much energy is converted in 1 second. The SI unit of power is the watt, which has a capital letter W as its symbol. Many electrical appliances indicate their amount of power or power rating. Appliances can be switched on and off without affecting each other. If they are connected in series, switching off one appliance would cause all to turn off. Parallel circuits allow you to use multiple appliances at once. Most people rely on electrical appliances. However, we have to pay for the electrical energy we use. Electrical boards measure energy consumption using electrical meters in homes. The unit of energy used is called a kilowatt hour, kWh. Electrical meters can either be analog displays where the dials rotate for each digit, or they can be digital displays where numbers change and can be read directly. Every month, the electricity supplier sends someone to read the meter. The amount of kilowatts used for the month is then recorded, and you are charged accordingly. In addition to the current you use, some companies make you pay a standing charge even if you did not use any electricity. That's why if you go on vacation, you will still have to pay for electricity. An analog meter has dials. Each dial represents a digit of the present reading. The dials move both clockwise and counterclockwise. The dials are read from right to left, and the numbers are written in the same order. When the hand on any dial is between two numbers, the smaller number is read. The hand in the clock on the right, which is between 4 and 5, so we write the number 4 down. When the pointer seems to be directly on a number, write that number down. When the number is in between 0 and 9, 0 is considered as 10, hence 9 should be written down. And when the number is in between 0 and 1, 0 should be written down. So here you can try to complete this exercise. Right, so the next number will be 9 because it's between 9 and 0, where 0 is seen as 10. Then the next number will be 6 because the hand is directly on number 6. And then the next number will be 2 because the hand is in between 2 and 3. So you would write the lower number down. Let's try some more. Look at the exercise carefully. Did you get 04998? Remember to read from right to left and write them from left to right. Let's try some more. Did you get 62035? Great job. To determine the amount of electrical energy used, subtract the previous reading from the present reading to determine usage. The total cost is calculated based on the cost of 1 unit. So if the previous reading is 46472 and the present reading is 46492, you subtract 46472 from 46492 and we see that 20 units or 20 kilowatt hours has been used. If 1 unit costs 20 cents, then the consumer would pay 20 units multiplied by 20 cents to give you $4. The power rating of the appliance and the time frame in which it is used are needed in order to find out the electrical energy used. If a light bulb of 15 watts is used for 2 hours, then the amount of electrical energy used is: first, convert 15 watts to kilowatts by dividing by 1,000, then multiplying by the amount of hours. So we get 0.015 kilowatts multiplied by 2 hours to give us 0.03 kilowatt hours. Kilowatt hours may also be referred to as units, just remember that. And so the kilowatt hour is the unit of energy shown on electrical bills and electricity meters. To go from kilowatts to watts, please note you have to multiply by 1,000. And then to go from watts to kilowatts, you need to divide by 1,000. Comprehension. In an electric circuit, a current can only flow if. You may pause the video to answer these questions. A current can only flow if you have a complete path, a conducting path, and a power source. Comprehension. Label the paths of the circuit below. Answers. A is the battery, B the switch, C the ammeter, D the conducting wire, E the bulb, and F the voltmeter. Comprehension. What type of circuit is in figure A and figure B? You may pause the video to answer these questions. Figure A is a parallel circuit and figure B is a series circuit. In the figure, the flow of electrons is depicting A. Conventional flow, B. Electron flow, C. Electron capture, or D. Radioactive decay. You may pause the video to answer this question. Correct. It's B. Electron flow, because the electrons are leaving the negative end of the terminal and entering the positive end. Comprehension. How do the two types of circuits differ? And list 4 uses of electricity. You may pause the video to answer these questions. In a series circuit, current only has one pathway in which to travel, while parallel circuits have 2 or more pathways to travel. 4 uses of electricity are cooking, communicating, transportation, cooling, and lighting. Comprehension. List 4 sources of electricity and list 4 advantages of electricity. You may pause the video to answer these questions. 4 sources of electricity are a cell, a generator, a car battery, and mains supply. 4 advantages of electricity. Electricity is efficient, it's readily available, it can be transmitted over long distances, it does not pollute, and can be easily converted to other energy forms. Comprehension. Match the different forms of energy to their correct description. You may pause the video to answer these questions. Correct. Kinetic energy is energy an object has due to its movement. Light energy is energy transferred in electromagnetic waves, known as light waves. And electrical energy is energy transferred when an electric current flows around a circuit. Comprehension. Here we have statements, and we're going to determine if they are true or false. Statement 1. Energy cannot be created nor destroyed. Statement 2. The SI unit of power is the joule. Statement 3. All machines are 100% efficient. Statement 4. Chemical energy is converted to electrical energy and then to light energy, followed by heat energy when a torch is turned on. You may pause this video to answer the questions. Statement 1 is true. Energy cannot be created nor destroyed. Statement 2 is false because the SI unit of power is the watt. Statement 3 is false because machines are not 100% efficient and never will be. Statement 4 is true. When a torch is turned on, chemical energy is converted to electrical energy, which is then converted to light and then heat. Comprehension. True or false? Cold water is heated up to steam by using the radioactive atom uranium-235 in nuclear stations. Statement 2. 5,000 kilowatts is equivalent to 5 watts. You may pause this video to answer these questions. True, cold water is definitely heated up to steam by using the radioactive atom uranium-235 in nuclear stations. False, 5,000 kilowatts is not equivalent to 5 watts. When you're going from kilowatts to watts, you need to multiply by 1,000, and that will give us 5 million watts. Comprehension. What is the meter reading below? You may pause the video to answer these questions. Congratulations, the meter reading below is 74013. Very good. Remember, to convert between kilowatts to watts, you have to multiply by 1,000, And to convert between watts to kilowatts, you need to divide by 1,000. So here's a little exercise of conversions. You may pause the video to answer these questions. Yay! Did you get 2,000 watts for A? Did you get 45,000 watts for B? 780,000 watts for C? 6 kilowatts for D, 0.903 kilowatts for E, and 13 kilowatts for F? Excellent if you did. Good job. A consumer used 100 units or kilowatt hours of electricity in a month. The first 50 units were charged on a Block 1 tariff, another word for tariff is tax, of 60 cents per kilowatt hours. And the next 50 units were Block 2 at 70 cents per kilowatt hours. The fuel surcharge was 40 cents per kilowatt used. What did the consumer pay for their electricity? You may pause the video to answer this question. First, you break down the question. 50 units cost 60 cents each. That'll give you $30. Another 50 units cost 70 cents each. That'll give you $35. That's the Block 1 and Block 2 charges. The fuel surcharge was being charged on the entirety of all units used. So it'll be 40 cents times 100 units to give us $40. The cost of the electricity bill would include Block 1 charge, Block 2 charge, and the fuel surcharge to give you a total of $105. A consumer used 200 units or kilowatt hours of electricity in a month. 50 units were charged on a Block 1 tariff of 60 cents per kilowatt hours, and the next 150 were Block 2 charged at 70 cents per kilowatt hours. The fuel surcharge was 40 cents per kilowatt hour used. What was the total electricity bill? You may pause the video to answer this question. Take your time. Did you break it up? If you did, you should get $175 for the cost of the electricity bill. Good job! Woo! Okay, here are some activities to do on your own. Draw a circuit with 3 bulbs in series, including an ammeter, a switch, and a cell. Draw a circuit with 3 bulbs in parallel, including an ammeter, a switch, and a cell. And then we have, what is the problem with buying a string of lights which are arranged in series, and then are the lights at home arranged in series or parallel? Explain how you decided on your answer. The next exercise is a story. You awoke to find yourself in a world of no electricity. In a group, write a 1 to 5 minute speech or dramatic presentation on the topic above. Discuss the uses, advantages, and sources of electricity. Give your story an interesting title. Please note that all answers are available at the end of this video. If you have this drawing drawn in your books, great job! And here is the answer for the second question. Alright, so if one bulb blows, it will cause a break in the circuit and the rest lights will not light up. This is because there is only one pathway for the current to flow. Lights in our homes are arranged in parallel because if one blows, all of the rest appliances in the house will continue to work. This is because there is more than one pathway for the current to flow. Okay, so how do you think you're gonna go about writing the story? It says you awoke to find yourself in a world of no electricity. We need to consider the following when we're writing our story. You have to consider a setting, a plot, some conflict, maybe some characters, or you might be the only character, a theme, a point of view, tone, and style. And it's not supposed to be long, so because it should be only between 1 and 5 minutes. So maybe a page, maybe a folder leaf. So you can give it a go. Here is an example. This story is entitled Click. You can see from the title that it's going to be quite interesting. Click. The day I won the lottery was the day the lights went out for the entire world. I had 60,000 subscribers on TikTok and Instagram combined. Not bad for someone the algorithm was not designed for. My platform had recently grown because of my recent obsession with buying lotto tickets and vlogging it with the hopes of winning the jackpot. And just my luck, the New Age apocalypse hit on the same day I heard my winning numbers. I was airing my live and my viewers just kept on increasing. At least 700 persons per minute were tuning in by the time the second lotto number matched. With 1 million views in under an hour, the feeling was surreal and the excitement was beyond comprehension. When the last number was called, the lights went out, leaving me shocked and in darkness. That was a week ago, before it became apparent that the entire world was experiencing an all-out blackout. A new world and a way of thinking and living was upon us. All hope was not lost because renewable energy was now of the utmost importance. The scientists had been warning the population about this happening 100 years prior, but no one was listening. No one ever listens to the scientists. All nations now had to fully invest in renewable energy that will be efficient and sufficient enough for everyday use. Countries like China, Iceland, Norway, and Sweden have proven that it was possible for years, but many failed to follow suit. When all of the oil, natural gas, and most of the radioactive elements ceased to exist, gas prices skyrocketed. These were signs, big signs of impending change, but small nations like mine did not prepare properly. We were suffering from the aftermath because of a lack of communication and transportation, and even the basic needs we took for granted, like lighting and cooking, were now a luxury. Using renewable energy forced us to appreciate the world around us, and in a weird sort of way, it also forced us to heal the world slowly from years of neglect. For the first time in a century, carbon dioxide pollution had fallen by 50%. The hospitals reported at least a 70% decrease in respiratory illnesses due to air pollution, and the scientists reported that the polar bears were not going into extinction anymore because the polar caps were not melting as fast. The Federation of St. Kitts and Nevis had invested in solar and hydroelectricity because of the large amounts of sunlight we receive every day, and because we are surrounded by the ocean, we have access to it. The initiative created many new jobs for Kittitians and Nevisians. Many other Caribbean islands did the same, and we were able to sustain ourselves very well. Although the initial setup for installing solar panels and propellers in the sea was expensive, in the end it all paid off. Now, every building in my country has a roof covered with solar panels, and all windows are made of solar cells. The cars we drive are even electric. The infrastructure is so different now. As for me and my winnings, I did get to claim it 6 months after the lights went out. A total of $10 million. What I'm doing with it is another exciting story for another day. I still have my TikTok and Instagram channels, 1 million subscribers combined and counting. Thanks for watching this lesson in electricity. I hope you enjoyed. Bye!